Hey class, hi, hello, namaste, adab, sat sri akal, assalamu alaikum, vanakkam and khamba khani to all of you. Welcome to today's class, and as you all know, this is your ICSE 10th in one shot, and the topic today which we are taking is the topic circles. Since it is a one shot video, I will be quickly going through all the theorems that we have learned in this topic. If you want to learn the proof of these theorems, you will have to refer the topic under the Umang series, because in Umang series I have done the proof as well, right? So before I start the class, I would like all of you to share the session right now so that maximum students can join and they can learn this chapter at once, right? So please don't forget to share the video. Also, please don't forget to like the video and share the video if and subscribe the channel if you are new here. Okay, so let's start the class. So the first thing that we'll learn, circle. So circle is defined by circle is a figure which is defined by what? By joining all the points in the plane which are at a constant distance from a fixed point in the same plane. That means from the center, all the points which are at equal distance, then this part will be forming a circle. So the line joining any 2 points on the circle is called a chord. The distance between the center and any point on the circle is called radius, and diameter is double of the radius. Also, diameter is the longest chord of the circle. Diameter is the longest chord of the circle. Okay, so the next part is circumference. Circumference is what? Perimeter. So length of the boundary. Circumference, as we all know, is equal to 2 pi r. Okay, after that, concentric circles. Concentric circles means circles having the same center. Circles having the same center and different radiuses. So all these circles have the same center over here, but they all have different radiuses. So they are called concentric circles. Equal circle means two circles having the same radius. Okay, after that, arc. So remember, arc is a part of the circumference. Remember this thing. Arc is the part of the circumference. What is an arc? Arc is the part of the circumference, and as you can clearly see, suppose if I talk about CD, it will be called minor arc, and if I talk about this CABD, this part, then this will be called a major arc. Okay, this will be called major arc. Now, segments and their relationship with arc. So these are the theorems which we have already studied. The angle subtended by an arc at the center is double the angle subtended by at any point on the remaining part of the circle. For example, suppose this is a circle we have, and this one arc we are talking about. So whatever angle this arc or this chord is subtending at this center, okay, suppose if it is x, so in the remaining part, so other than this part of the arc, anywhere else on the circle we join it, it will be half of this, x by 2. So we can clearly say angle at the center is double of the angle at the circumference. Okay, if we talk about a case of major arc, मान लो major arc, if we are talking about this major arc, and this major arc is subtending an angle of x degree, so in the remaining part, somewhere over here, it will be x by 2 degrees. Okay, the next thing, angle in the segment of a circle are equal. Angles in the same segment will be equal, because if I take any part over here as well, yahan bhi if I will take it, this will be x by 2 only. So angles in the same segment, because they both are half of the same thing. So angles in the same segment are equal. The last part is of the semicircle. So what does it say? That if we have a circle and if I draw a diameter, so this diameter or this semicircle is holding an angle of 180 degree at the center. So in the remaining part, it will be half of 180, which is 90 degree. So remember, angle at the semicircle is always 90 degrees, right? After that, we have cyclic properties. So first we need to understand what is a cyclic quadrilateral. So a quadrilateral whose all the 4 point lies on the circle. Remember, suppose if it is a circle, and if I choose any 4 points on the circle, and if I join them, then the figure obtained will be called a cyclic quadrilateral. Right? So remember, all the points or all the vertices of the cyclic quadrilateral lies on the circle. Lies on the circle. So for example, if I talk about something like this, okay, if I ask you, beta, is it a cyclic quadrilateral? So you will say no. It is not a cyclic quadrilateral because this vertex is not on the circle. Okay. Now the main theorem about the cyclic quadrilateral is, suppose this ABCD is a cyclic quadrilateral. Remember, the opposite angles are supplementary. That means if this angle is x, this angle will be 180 minus x. So we can say angle A plus angle C will be equal to 180 degree, and angle B plus angle D will also be equal to 180 degrees. They both will be 180 degrees. Okay. The next part, exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So suppose if we have this exterior angle over here, exterior angle for any cyclic quadrilateral will be equal to interior opposite angle. So there is one angle interior to it which is adjacent over here. Opposite to that you have this angle over here. So these two angles will be equal to each other. These two angles will be equal to each other. Okay. After that, tangent. So see, with a line and a circle we can have three possibilities. First case, when the line does not touch the circle at all. Second case, when the line cuts the circle and it is cutting the circle at two different points. In that case it will be called a secant of the circle. Okay. And the third case, when the line is drawn in such a way that it just touches the circle at only one point, then this line is called the tangent of the circle, and the point where it touches the circle is called point of contact, POC. This point is called what, beta? It is called point of contact. Okay. Now, number of tangents which we can draw from a point on a circle. So if we have a circle over here, and if I have to draw a tangent from this point which is on the circle, you can only draw one tangent. You can only draw one tangent. Okay. Then we have a theorem, that is that if suppose this is the circle and we have drawn the tangent from a point on a circle, that is this AB. Remember, this radius which is joining the center with the point of contact, this OP will be perpendicular to the tangent. So the theorem says radius at the point of contact is perpendicular to the tangent. OP will be perpendicular to AB. So wherever any tangent is there, whatever is the point of contact, if you join that point of contact with the center, so this radius is going to be perpendicular to this tangent. This is what the theorem says. Very important theorem. Okay. Next part. So this was the tangents which, when we have drawn the tangents from an external point. Okay. So this is the case when we have drawn the tangents from a point on the circle. Now, if we draw a tangent from an external point, so in this case we can draw two tangents. In this case we can draw two tangents. So remember, beta, suppose if it is the point of contact A, if it is the point of contact B and P. So if I join P with A and P with B, remember the line joining OP. So remember, first thing, triangle OAP will be congruent to triangle OBP. Proof is very easy. Right angle, hypotenuse and side rule. Right angle, hypotenuse is the common hypotenuse. OA and OB both are equal to radius. So that's why by RHS rule they are congruent. First thing. So from here, if they are congruent, we can say the following results. First thing, the length of the tangents will be equal. PA is equal to PB. Second thing, I can say both the tangents are at equal angle with OP. So third thing I can say is that angle APO is equal to angle BPO. And the last thing, this angle will be equal to this angle. Angle AOP is equal to angle BOP. Got it? These are the four results which we have got simply by proving the congruency of both the triangles. After that, we have a rule that if two chords of a circle are intersecting either internally, so this part is called internally and this part is called externally. No matter how they are intersecting, whatever it happens, the chords, the product of their segments will be equal. This theorem can be proved by proving these two triangles similar and these two triangles similar. So the result is AP into BP is equal to CP into CD in case when the chords are intersecting internally. And suppose this point is again P. If I say P only, same thing again. AP into BP, same thing. A to P and B to P. So AP into BP is equal to CP into DP. Sorry, CP into DP. Here I have written wrong. PD कर लेते हैं. AP into BP is equal to CP into DP. Simple thing. Okay. After that, you have this thing that remember, if we have a tangent from a point P, if I am drawing a tangent to the circle as well as a secant to the circle, remember this thing, PT square. The square of the tangent will be equal to the product of the segment, that is PA into PB. The proof I have done in the Umang series videos, very important, go through them as well. Okay. And last part is the angle between a tangent and a chord through a point of contact is equal to angle in the alternate segment. How do you solve this? See what I am saying. Suppose if I'm talking about, let's say this chord. If I'm talking about this chord PQ, let's say I'm talking about this chord PQ. This chord PQ is making some angle over here. This angle will be equal to, see, this is the tangent, this is the chord. So angle between these two will be equal to the angle in the alternate segment. So they are making, this is one segment, the alternate segment is this part. So here in this segment, this angle will be equal. You know angles in the segment are equal. So anywhere, this angle and this angle both will be equal to each other. This angle and this angle both will be equal to each other. This is also called alternate segment theorem. Okay? So this is all the theorems which are there in your syllabus. If you want to revise the theorems, the proof of these theorems, refer to Umang series videos. Now, those students who are feeling difficulty right now and are facing a problem that how am I going to appear in my examination, you have a very good opportunity at Vedantu. So you can subscribe to Vedantu's Pro subscription. There you will be getting unlimited classes, okay, and you will be able to download the notes, your doubts will be solved, everything at one place. Okay, so the link for the registration is mentioned in the description box of this video, or it will be also there in the pinned comment. Remember, use the code GPE Pro to get 20% off. Okay, now let's solve some questions better. My first question, what it is saying, we have angle CAB as 75 degree, angle CBA as 50 degree. This is B, okay. This is B. This is D. So this is 75, this is 50. Find value of angle DAB. Matlab this angle plus angle ABD. This angle. Correct? So sum of this angle and this angle I can easily find out if I get to know what is this third angle in this triangle ABD. Right? So what I will say now, ki sir, first thing I know, if I look carefully, if I look at the triangle ABC, okay, if I look at the triangle ABC, I can clearly say, sir, in triangle ABC, one angle is 75 degree, one angle is 50 degree, so I can clearly get the remaining angle, right? So I can say 75 degree plus 50 degree plus angle ACB is equal to 180 degrees. Yes or no? Correct. So after this we have got 125 degree plus angle ACB is equal to 180 degree. From here you have got angle ACB is equal to 55 degrees. This angle is equal to 55 degrees. Now focus ahead. Aage socho. Let's look carefully. Yaar, this angle is 55. I know AB is a chord. AB is a chord and AB is making one angle in this segment over here and the other angle in this segment is over here. And we know angles in the same segment are equal. So if it is 55, this angle will also be 55 degree. So I can clearly say, sir, angle ACB is equal to angle ADB. Both will be equal to 55 degrees. Right? Now, let's talk about the triangle ABC. Let's talk about triangle ABC. Okay, so I can say that sir in triangle ABC. Okay, I can say that sir in triangle ABC we have, sorry, ABD, in triangle ABD, this triangle ABD, we have angle DAB plus angle ABD plus angle ADB is equal to 180 degree. अब देखो, I don't know what is DAB, I don't know what is ABD, but I know angle, sorry, ABD I don't know, but I know angle ADB is equal to how much? 55 degree is equal to 180 degree. So you can clearly say angle DAB plus angle ABD is equal to 180 minus 55, which is equal to 125 degrees. It will be equal to how much? It will be equal to 125 degrees. Okay? It will be equal to 125 degrees. Got it? So your answer is what? 125 degrees. Next question. ABCD is a cyclic quadrilateral with center O. If angle ADC, this angle is equal to 130 degree, find angle BAC. This angle we need to find out. You can clearly see they have clearly shown ABCD is a quadrilateral. So AB is a diameter. AB is a diameter. So I can clearly say, sir, this angle ACB must be 90 degree. Angle ACB is equal to 90 degree. The reason being angle at the semicircle. Angle at the semicircle. This angle is 90. Also, ABCD is a cyclic quadrilateral. So I can say angle ADC plus angle ABC must be equal to 180 degree. Reason being they are opposite angles of a cyclic quadrilateral. Opposite angles of a cyclic quadrilateral. So ADC is 130 degree plus ABC I do not know. I don't know is equal to 180 degree. So we have got angle ABC as 50 degrees. Okay. So this angle is how much? This angle is 50 degrees. This angle is 90. So clearly the angle BAC, use angle sum property in triangle ABC. So in triangle ABC, 90 plus 50 plus angle BAC is equal to 180 degree. From here you will get angle BAC is equal to 40 degrees. So our angle, the required angle is equal to how much? It is equal to 40 degrees. Okay, beta? This is how this question will be solved. Okay, let's go for the next question. In the figure given below, find BCD, ADC and ABC. All show steps of your working. Obviously we'll show it, right? So by first thing I can clearly see ABCD, all of them are lying on the circle. So ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. If it is a cyclic quadrilateral, I can say angle DAB is equal to angle DAB plus angle BCD will be equal to 180 degree. So angle DAB plus angle BCD is equal to 180 degree. Angle BAD is 105 degree plus angle BCD we don't know is equal to 180 degree. So angle BCD is equal to 75 degree. So now this angle is equal to 75 degree. After that, if I want to get angle ADC, so beta I can clearly say this angle at A and angle at D, they both are interior consecutive angles. See, this arrow shows that these two lines are parallel. So I can clearly say, sir, angle A plus angle D is equal to 180 degree. This time the reason is interior consecutive angles. So angle A is 105 plus angle D is 180 degree. So here you have got angle D is equal to 75 degrees. And again, I can either say angle B plus angle C is 180 degree because of interior consecutive angles, or I can say angle B plus angle D will be 180 degree because of the opposite angles of a cyclic quadrilateral. Your angle B will be equal to 105 degrees. है ना? ये वाला भी 105 हो जाएगा. Either by consecutive angles or by opposite angles of a cyclic quadrilateral, you will get your answer. Okay, chalo, let's go for the next question. Next question is this. Listen, this question is very important question. What this question is saying: AB is a diameter and AC is a chord of a circle with center O, such that angle BAC is 30 degree. Okay, sir. AB is diameter, center is O. This angle is 30 degree. The tangent to the circle at point C intersect AB produced at D. Okay, this point D over here. So CD is a tangent and this AB produced is intersecting at D. So AD is a straight line. Show that BC is equal to BD. अब देखो, I have to show BC equal to BD. So obviously, one way or the other way, I have to play with the angles. Angles, if I prove in triangle BCD ki two angles are equal by isosceles triangle property, I can get BC equal to BD. So try to get as many angles as you can. Okay. First thing, better look over here. Your BC is a chord. BC is a chord and it is subtaining an angle of 30 degree at the circumference. So the angle at the center will be double of it. So this angle is 60 degree. So I can clearly say, sir, angle BOC is a double of angle BAC, which means 2 into 30, which is equal to 60 degree. Reason being, angle at center is double of angle at remaining part of circle. Got it? Okay, sir. So this angle is 60. Also, one more thing I know now, that, sir, what do we know next? Next thing is, sir, we know that in triangle BOC, we have BO is equal to CO, both are equal to radius. This is radius, this is also equal to radius. So if these two angles are equal, I can say this angle will be equal to this angle, right? So let's say both these angles are x. So I can say, sir, angle OBC is equal to angle OCB, both are equal to x degree. So in triangle BOC, x plus 60 is equal to 180 degree. You will get 2x is equal to 120. So x is equal to 60 degree. That means all the three angles are equal to 60 degrees. So I can say triangle BOC is equilateral triangle. Triangle BOC जो है बेटा, that is your equilateral triangle. ठीक है, अब बात करते हैं आगे की. Okay, let's move ahead. Okay, next part. Yeah, look at this angle. I can say that, sir, angle DBC and angle CBO, they are linear pair. So I can say, sir, angle DBC plus angle OBC, they both are equal to 180 degree because it is a linear pair. So angle DBC I do not know, but I know angle OBC is 60 degree. So is equal to 180 degree. You got angle DBC is also equal to 120 degrees. ठीक है बेटा, you have got this angle is equal to what? 120 degrees. All right. Okay. So till now what we have done, we knew that this angle is 30 degree. So we got to know that angle at the circumference will be angle at the center is double of the angle at the remaining part of the circle for this chord BC. So this angle became 60. Then I have used angle sum property in this triangle BOC. Since BO and CO were equal, these two angles we got it as 60 degree and this one also as 60 degrees. After that, I have used the linear pair and I have got this angle as 120 degrees. Okay. Now the next thing, what I know beta here is ki, sir, I know OC is a radius at the point of contact. So this complete angle, ये जो complete angle जो है बेटा, this complete angle must be 90 degree. Angle OCD is equal to 90 degree because radius at point of contact is perpendicular to tangent. Okay, sir. So if this total is 90 degree, if this part is 60, I can easily say this part will be 30 degree. So angle OCB plus angle BCD is equal to also angle OCD, which is 90 degree. So OCB is 60 plus BCD we don't know. So BCD is equal to will be equal to 90 degree. Sorry, 30 degree, 30 degree, 30 degree, 30 degree. So this part is 30 degree. This part is 60, this part is 30. Now come to the part of triangle BCD. Now I can say that sir, in triangle BCD, by 120, one angle is 120, other angle is 30, plus angle BDC भी निकाल लेते हैं, is equal to 180 degree. So we can get from here angle BDC is also equal to what? 30 degree. So this angle now is also equal to 30 degree. So I can say in triangle BCD, angle BCD is equal to angle BDC. Both are equal to 30 degree. So the side opposite to them will be BD and BC. So from here I can say BC is equal to BD. From here we can say that BC is equal to BD. Got it, beta? So this is how only we have played with the angles and we have got our answer. Okay, got it? Let's move to the next question. The next question coming to your way is this. If PQ is a tangent to the circle at R, calculate angle PRS and angle ROT. Okay, we need to calculate angle PRS and angle ROT. Very easy part. Take the first thing. Here I know if this angle is 30. Dekho, this is one tangent. This is one tangent. Okay. This is the radius at the point of contact. So I know this angle must be 90 degree. If this much angle is 30, the remaining part must be 60 degree. So I can say, sir, angle ORQ is equal to 90 degree and angle ORQ is equal to angle ORT plus angle TRQ is equal to 90 degree. So from here angle ORT plus TRQ is 30 is equal to 90. So we have got angle ORT is equal to 60 degrees. The reason here being radius at point of contact is perpendicular to tangent. Alright. So this angle is 60 degree. Now once we have got this angle as 60 degree, also I know that sir in triangle ORT, OR is equal to OT. OR is equal to OT because both are radius. So I can say sir angle ORT will be equal to angle OTR. Both will be equal to 60 degrees. Both are equal to 60 degrees. So I can clearly say, sir, in this triangle ORT, 60 degree plus 60 degree plus angle ROT is equal to 180 degree. From here you get your value of angle ROT as 60 degrees. Chalo. We have solved this second part first. We have solved, that is angle ROT is equal to 60 degrees. Okay? Angle ROT is equal to 60 degrees. अब एक और तरीका, this can be solved in many ways. बेटा बहुत तरीके से solve कर सकते हैं. One more way is कि देखो I know this angle will also be 90 degrees. Angle PRO is equal to 90 degrees. अच्छा, before I show that angle PRO is equal to 90 degrees, before I show you this, but one more thing I would like to tell. Sir, I know obviously, I know this angle will be 90 degree. Because ST is a diameter, so angle SRT is equal to 90 degree because angle at the semicircle. So angle SRT is equal to angle SRO plus angle ORT is equal to 90 degree. Angle SRO beta I do not know, but I know angle ORT is equal to 60 degrees, right? I know angle ORT in the previous part we have got this as 60 degrees. So clearly the remaining part will be how much? 30 degrees. Okay. So angle SRO we don't know, plus 60 is equal to 90. So angle SRO is 90 minus 60, which is equal to 30 degrees. So this angle will be equal to 30 degrees. ठीक है sir. One more thing. यार I know sir this angle PRO, ये जो angle PRO जो है sir, this angle PRO also will be 90 degree ना. Radius at the point of contact is perpendicular to the tangent. So angle PRO is also equal to 90 degree. And angle PRO is made up of angle PRS plus angle SRO is 90. So angle PRS I don't know plus angle SRO we just found it as 30 degree is equal to 90. So angle PRS will be equal to 60 degrees. Khatam, done, 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 done. So this angle will be equal to 60 degrees. Got it? So angle PRS we have got it as 60 degrees. Angle ROT also is equal to 60 degrees. Both we have got it as 60 degrees. Okay, beta? So this is how this question should be done. Remember this thing, it is very important to revise the topic starting with the theorems, all the theorems, their proof also. Please don't forget to practice. Okay, so as I was telling you earlier, if you need any help in your final preparation of your examination, the link for that to register for Vedantu's Pro subscription is mentioned in the description box as well as in the pinned comment section. The coupon code is GPE Pro to get 20% off. Okay, the prices are mentioned over here. This is the price for 1 month. This is the price for 3 months. Remember, it includes all the subjects: maths, physics, chemistry, biology, SST and English. Everything it includes. Very affordable. Those who can afford these courses are most welcome to join the course. Okay, this will be your link. This will be your code to get 20% off. GPE Pro. Okay, beta. So this is all in this chapter. Please practice these questions. Also, especially the proof of the theorems. If you have not done it, watch the Umang series videos in which I have done them in detail. Okay, beta. So this is all from my side. I hope all of you enjoyed this session. Thank you so much for coming to the session. Please don't forget to like the video, share the video with your friends and subscribe to the channel. I'll see you soon. Bye-bye. Sayonara, Khuda Hafiz to all of you. Bye-bye.